Hello and welcome back to this series on BookNLP and Python, and this is all kind of geared towards beginners. Now, in the last two videos, I taught you how to install BookNLP, generally what BookNLP was, and I introduced you in the last video to this new textbook that's coming out with it, and we started to look at how to actually generate what we call the output files, which is really where all the information that BookNLP does for you, this is where it sits. In this video, I'm going to go through and explain these output files step by step, starting with, I believe in the textbook, I start with, let's scroll up and see the tokens file, and I'm going to be following this textbook throughout this video. So if you want to follow along, open it up in another window or another browser, but just sit back and relax. I'm going to give you some tips for kind of in this video going through and taking these output files and actually starting to get them into more readable, structured text. Now, the reason for this is because let's open up one of these. What you're going to have is a series of either TSV files or tab-separated files. That's what the tokens file is, so let's take a look at that. And within Jupyter Lab, you might be able to see this on your screen. We've got these kind of indentation notes. This is what indicates a tab. So this is what separates a piece of data. In this case, what we're seeing up here are all of the different headers. So these are all the different columns that you'll have in this, if you want to think about it in Excel terms, in this spreadsheet. But we're going to be looking at it with pandas and Python, and I think it makes it a little easier to kind of analyze for our purposes and also just generally to get a sense of it. Because reading a TSV file by just your eyes is very challenging because not all the columns will align correctly. So let's go ahead and try to do that. If we go to the textbook, we'll see what's kind of covered in this chapter. And if you scroll down, we're using pandas here. Now, if you don't know about pandas, I have a whole textbook at pandas.pythonhumanities.com. And I've actually just recently added it to the new Python 4DH textbook, which is at python-textbook.pythonhumanities.com. And it'll introduce you to pandas. For right now, just think about pandas as a way of handling tabular data, or data that you might typically see in something like Microsoft Excel, or some kind of spreadsheet. And all this bit of code here is doing in this textbook is it's importing the library of pandas as PD, which is the Pythonic way to do it, and it's reading in the CSV file. Now, even though this is a .tokens file, it's actually structured as a standard CSV file, but it's not a CSV or comma-separated value. Rather, it's a tab-separated value. So the delimiter that I have passed here is a delimiter of a /t. So anytime it sees a /t, it parses that and recognizes that as a new piece of data. And when you do it, you get an output that looks kind of like this. Believe it or not, what we're seeing right here in this nice, easy readable data frame is the exact same as all of this. So let's go ahead and take a look at this output file, the .tokens file, and see what's contained within it. So if you look at it, you've got a lot of different headers, or a lot of different columns. I'm going to break down piece by piece what each of these are. And if you ever get lost and you want to come back to this video, great. If not, a lot of what I'm covering is covered right here in this nice little handy dandy list, essentially. So what we have is, and I think this is a little easier to read if it's as a data frame. So the first thing we've got is this paragraph ID. So a good way to think about, and if you know about Python already, you know that you start at 0, it's a 0 index language. So you start at 0 and you increment up from 0 to, in our case, 2,995. What does this mean? Well, this is the index for the paragraph. So paragraph 1 would be 0, and then paragraph 2,996 would be paragraph 2,995. So you just got to kind of keep that in the back of your mind that you're starting at 0 and working your way up. Now, this paragraph ID will increment each time a new paragraph is identified. And one of the ways I think that this happens is by a double line break in a text file. That'll indicate a new paragraph. And so each time a new paragraph is found, it increments up by 1. Now, the sentence ID, this is the exact same thing as the paragraph ID. It'll start at index 0, so the first sentence found will be 0, and it'll increment all the way up. So in our case, we've got 6,885 sentences in all of Book 1 of Harry Potter. Now, the next thing here, this is where it gets a little trickier, is token ID within sentence. So this is going to increment up starting at 0 each paragraph and then reset, within each sentence, and then reset when that sentence changes. This is really important for certain NLP tasks where you need to work on a sentence by sentence basis. And so it's really nice that it's actually included for you in this. Now, the token ID within document, this is going to be the occurrence of a token. So this could be a punctuation or some kind of word in a text. And it's going to start at 0 because it's going across the whole document. It's going to go all the way up to the end. So in our case, it's going to end with 99,255. And we notice that this last thing is actually a /t. So let's brings us to our word column. So what's word? Well, in spacey terms, a good way to think about word is as a tokens.text. So this is going to be the raw text that is that token. So in this case, the first word of Harry Potter is Mr., and I believe it goes, Mr. and Mrs. Dursley, and it continues on. So that's what you're seeing here. And notice that you also have commas rendered as unique tokens. So this is when a token is a punctuation that has a dedicated syntactic value. When a punctuation is functioning in English as an abbreviation indicator, it's oftentimes in most libraries going to be linked into that single token. So Mr. period is 1 token. Mrs. period is 1 token. So that's what the word is. Now lemma, a good way to think about lemma here is as a root word. It's a little different, but it's using lemma here because it's wrapping around spacey, which uses lemma. I believe NLTK or Stanford will use root. Think of lemma and root as kind of synonymous. I go over how they're different in my NLP textbook, but for right now, just think about lemma as the root word. So if you have a verb, think about its root base deconjugated form. So you can link all variations of a verb in across a text to be the same thing. So a good example of this is to be would be, and it could be is, was, were, etc. on down the list. All forms would have the same lemma, in this case, be. Now, byte onset and byte offset, this is going to be the start and end character. So think about M being 0 and the period being 3. So this is going to allow you to identify at the byte level where a word or a token starts and ends. This is really useful if you need to essentially parse a document based on the start and end character to do some basic string extraction from the text. Not always going to be helpful, but it's nice that it's there so you don't have to do it manually. POS tag, this is going to conform to the spacey tag system. If you do want to know about these, check out the textbook spacey.pythonhumanities.com. I go over what all these actually are, and I do the same thing with the fine POS tag, which is going to be a finer specification of what the part of speech actually is. And POS stands for part of speech. So in this case, proper noun, which is going to be Mr., conjunction, which is going to be and so you get a different way this is represented on a finer level with the fine POS tag. Again, I covered that all in my NLP textbook. Dependency relation, this is going to be in Spacey's term, the .dep, the dependency that identifies kind of how it's functioning in the sentence. So in this case, the noun subject, compound, conjunction, being punctuation, etc. on down the list. And then finally, you get to the syntactic head ID. So this is useful for when you need to identify syntactic link, relationships between a word in a sentence with another word. So it's going to be the root of it. Again, if you want to understand about syntactic heads and why they're useful, this is more of an NLP subject. I'm not going to cover it right now, but if you want to learn about it, check out my videos on NLP. And then finally we have, and this is the longest file, I promise, is the event column. This is going to specify if an event was found in that sentence. And again, we'll be talking about events a lot more in the next video. So that's generally what you have here with the .tokens file. And if you want to kind of have a refresher or just kind of go back and read, I've got all these kind of listed out right here. But let's just jump on to the next file, which is the .entities file. Let's take a look at that over here in our Jupyter Notebook. So if our .entities file has these heads right here, and again, you should see this and recognize that this is the same as the last file. It's a TSV file. So let's go down and check out what this looks like, again, using pandas to read in the entities file and print it off. What do we have here? Well, we've got 6 different headers. So the first one is co-ref. This is going to be very useful as we see later on. This is going to be a unique identifier, and this file is going to contain all of the entities found within the text. So be it person, factory, place like a GPE or a lock, vehicle, etc. on down the list, all of these different entities are going to be extracted and stored in this file. And what you're going to see here in the co-ref column is the unique identifier. Think of this as an index that corresponds to a specific person. In this case, the NER didn't grab and extract what I call, in other pipelines I've developed, a spousal entity, which is when you have Mr. and Mrs. X, Y, or Z. So that spousal entity, when they're kind of talked about together, it's important to extract those for various reasons. One, it allows you to recorrect women's names oftentimes get removed when a spousal entity is used. And so it allows you kind of to deconstruct and reconstruct each entity separately. That's a separate story. But anyways, you see the first positive identification here with 92 belonging to Mrs. Dursley. Now this is very useful because if you notice, unlike most NER outputs, what you're seeing is pronouns being extracted as well. And you'll see this here in just a second when we talk about the prop category. So what you're actually seeing here is a unique ID being even used for pronouns. This is going to be very useful as we get to essentially the co-reference resolution portion of this talk, where you can take the pronoun and link it to the correct character. And we're going to see that all in just a little bit when we look at the .book.html file, which is a little easier to read. So that's what co-ref is. It's a unique identifier for each entity found within the text. So if we keep on going down this list, we got the start token. So a start token is the token's position in the text. And you'll notice that the end token in the next column is 0 and 0 for Mr. If you have a token that is only a length of 1, its start and end is going to be the exact same. So whenever you're trying to extract a token, always add an additional 1 so that you can kind of extract from that list and index the additional 1 so you can kind of grab the entire thing by itself. So our start token here and our end token here are going to be the same for Mr. However, notice that the start and end token here for Mrs. Dursley starts at 2 and ends at 3. So this isn't a case where you've got the start and end token each being represented with the start token being 2 and the end token being 3. And this is going to tick up for the entire text, so that by the time you get down to the last one, which is Dudley, you've got the start and end token at 999,251, and the same for the end token. So this allows you to do some complex text extraction later on. So if we keep on going down this list, we've got the prop category. So what prop is going to tell you is kind of the role of that token in the within the text. So is it a proper noun? That's what prop stands for. Or is it a pronoun, or is it just a nom here in this case? It'll tell you how it's actually functioning, if it's a pronoun or a proper noun. Those are the two that are most useful when you're trying to extract personal entities. Category, this is going to be the category of the entity. So person, fac being, fac stands for factory in an NER, but it can be anything. In this case, it's a street. You've also got per here that you're able to see. Oh, and these ... dots just indicate the data frame was too long to display, and it's just grabbing the first 5 and last 5 rows. The last category here is text. Again, this is going to be the raw text that you actually have, and so that's going to be the text that corresponds to this extraction. So that's all the .entities file is. And again, I've got an error that comes up occasionally for me, and if you see an error that looks like this, where it's BookNLP error, or sorry, not that error. It's an error that actually populates when you are trying to essentially display or extract the text and the co-reference resolution is off a little bit. You'll have to do some manual correction. Again, when you go back and look at the textbook, I'll have these images which are showing an error at the moment and not actually populating on the site. I'll have those kind of added in, and you'll be able to see what I'm talking about here in the textbook. So and it goes through step by step how to actually address and solve that problem. So the .quotes file, this is now the file that looks like this. And again, this is going to be tab separated value. So we've got quote start, quote end, etc. on down the list. And so what we're able to see with this is essentially all the different quotes found within the text. So let's go ahead and take a look. So you've got the quote start, quote end. This is where the quote starts and the quote ends. You've got the mention start and the mention end. This is going to be the person doing the speaking, where that indicator is at. The mentioned phrase is going to be the speaker in this case. In this case, it was he, they, he, Mr. Dursley. So it's going to be the person doing the speaking. And if we, let me just kind of zoom over a little bit. It's a little hard to read. Let me zoom down so I can zoom over. There we go. So we've got the mentioned phrase, the character ID. Now this is going to be that unique identifier that we saw a few seconds ago in the ent.entities file. This is so that you can correctly link who he actually is to a specific entity. And finally, the quote portion of this column is dedicated to the actual quote itself. So you've got all the quotes stored, but you also have all of this very, very important metadata kind of stored about the quote. And also, you've got the quotes in sequential order, right? So they tick up incrementally as a new quote is actually found and extracted. If we go down to supersense, we see another TSV file. So let's go ahead and take a look at supersense to get a sense about what that is. So again, if we look at the supersense as a pandas data frame, we see a start token and an end token. Now what you have here is a little different from an NER output. It looks like an NER output on the surface, but it's not. It's a bit more nuanced than that. It captures things that are really important because, again, BookNLP is designed for literature analysis. It's really good at capturing these kind of things like perception, act, time, location. So it's got some of those NER qualities, but it captures this broader kind of sensory elements, I guess is the best way to put it. And within this, you have the start token of that sensory word, that supersense word. The end token, again, you're starting at 0 and you're going to increment up. It's got the supersense category. So there's quite a bit of these. It's in the repository for BookNLP, but you can kind of get a really good sense of the different categories that are available. And then it also has the text itself. So the raw text. That's the supersense file. There's a lot to cover here with the different categories. I recommend kind of playing with the text that you're really familiar with and looking and analyzing the supersense file to get a better sense of it with your particular data. If we go down though to 3.7, the .book file, this starts to look a little different. The .book file is a massive JSON file. Now this can be actually it's very difficult, even though I read JSON files all the time, it's very difficult to parse this file because there is a lot in here. And that's a good thing, and you need to really understand how to actually handle it. So I've given you some code in this textbook that you can use to kind of analyze what's in this JSON file a little bit more easily. So we're going to be working with the JSON library, and if you don't know, a JSON file stands for JavaScript Object Notation. It's a really powerful data structure that allows for you to store hierarchical data outside of Python or any kind of programming language. And it can be loaded and parsed very easily by all browsers because it's meant to work alongside JavaScript, which is one of the main languages used for web design, essentially. And so what I have here is just loading up that data and taking a look at the different keys that are available. Again, if you need to think about keys here, this is a massive, massive dictionary that is just huge, contains a whole bunch of data, and as we're going to see when we get to the .book.html file, you can see a lot of that in that .html file a bit more easily. But if we look at the main keys, there's really only one key here, and that's characters. So that's kind of the way this file is structured. It's structured around the characters of the text. If we look at the length of characters, we see that there are 723 different characters, and if we grab just the very first character referenced, we see that within the characters, each character in the JSON file, we see that each character has all of these different keys associated with them, or values. So agent is the actions that a character does. Patient is the actions done to the character. So this is when the character is either the actor or the recipient of a verb action. Mod is the adjectives that describe them. So you're able to see all the different ways they're actually referenced, like the adjectives used to describe that individual. This is really good because it allows you to look at a character across an entire text and collect all the different ways that they're described. So Harry, being a smaller individual, would probably have the character or the modifier small included in there. POS, these are all the different things that the person possesses. Now, POS is very broadly defined, so it could be things that they own. So in Harry Potter's case, his broom. It could also be the things that he possesses with regards to familial or amicable relationships, so in this case, aunts, uncles. It can also be the things that he possesses as a human. So his body, his head, his back, etc. POS is very broadly defined. A good way to think about this is any time that Harry Potter or any character is referenced and it says his X, that's a thing that he possesses. So this is very broadly defined as any time that a genitive or a possessive descriptor is used for that person, it links up what that thing is that they possess. ID, this is the unique identifier that we've already seen. So if it's Harry Potter, I can't remember what his is at the top of my head, but I believe Mrs. Dursley was 93, I think. You'll have to go up and check. But G, this is going to be the analysis about gender pronouns. Now, this is probably one of my favorite things about BookNLP, and this is why I think it actually has wider applicability beyond just literature, but actually for historical documents. So it's oftentimes very delicate to assign gender to a person that you find in a historical text. There are some salutation indicators, and this is used by BookNLP. So things like Mr., Mrs., etc. to identify if it's a male or female. But a lot of the times you have to just go based on two things, and this is very problematic. You can go by their name. Does their name more often align with one sex over the other, or is it unisex? Highly problematic to do that. I don't encourage it. In fact, in all of my research, I don't do that. So don't do that method. The other method is to identify the pronouns that are assigned to that person. This is a little bit better. And what BookNLP does really well is it takes in the non-binary nature of pronouns. So it allows for you, it actually is able to identify non-binary pronouns and extract them and associate them with a character. Most importantly, because BookNLP is using a lot of machine learning, and a lot of that is not going to be accurate 100% of the time, you have to accept that, it stores all that information. And so what the G, and we'll see this kind of down below, what G actually has in there is all the different gender pronouns used and the times and frequency in which one is used. And it also gives you the predominant pronoun set used. So that you can, if you want to, use it to do gender identification. And so you're also able to back that up with raw data for the frequency at which certain pronouns are used for an individual over others. Again, this is a very delicate area, and so BookNLP, I think, tackles it very, very nicely. I'm using it right now in a couple different projects just for that category there. Count, this is the number of times that the entity appears in the text, so it kind of just keeps on ticking up, and you'll see that value represented by count. Mentions, this is how the character is actually referenced within the text. So you can kind of get all those, and you'll see that the character mentions has a few different categories. So it's got proper, common, pronoun. Think of proper as like the proper noun. So Mr. Harry Potter, Harry Potter. Common would be the pronouns like he, his, him, etc. Common, I can't remember what common is off the top of my head, but again, it's in the BookNLP documentation. So you're able to kind of see all of that right here. So what I did in this textbook is I went through and I kind of demonstrated each of these different categories one by one, so you can kind of see them all printed out. And this is what I was talking about, the output for the G category or the gender. You're able to get the inference. The inference is going to be the statistical likelihood that Harry Potter is a he or a him or a his, so likelihood that it is a male. And as we can see, he is sometimes referenced as they, them, or their. This is common in English. So he's probably referenced in part of a group in these scenarios when he's mentioned alongside Ron and Hermione, most likely. And then she or her, I would venture to guess that in these situations, this is a false positive. I'd have to go back and check to see what's happening here. But what you're having is the high likelihood, in this case, the majority of the time, he is referenced as he, him, or his, based on the output of the ML model. So that's really, really useful. And again, if you want to kind of get a sense of what all these are, go to the textbook. I've got it all kind of laid out for you. And this is how I really recommend thinking about and parsing these kinds of files, because it allows you to kind of get a sense of what's in them. This is going to be very useful in the next two videos as I start to write some scripts for you to actually analyze these files and extract really kind of data that you probably need to answer more general questions. Now, this final file, and this is what I think is going to be useful to explore right now, is this .book.html file. So I'm going to go ahead. I've got it stored. I think it's easier to parse when we actually open it up within the browser. So I'm pulling it up right now to open it in Firefox. Okay, so here we are. So we've got named characters up at the very top. These are all the named characters. So let's take a look at Harry. He occurs 2,029 times. He's referenced as Harry. He's referenced as Potter, and we can see this because there's a slash, and it tells us how many times he's referenced as Harry. So in this case, he's just called Harry 665 times. He's just called Potter 46 times. He's called Harry Potter 23 times, and the list goes on. It even captures really nuanced things like the famous Harry Potter. Let me zoom in just a little bit so it's easier for you to read. And we can go down the list. Hagrid, we see right there. And we see some false positives where Hagrid is referenced as Harry. Again, you're going to have some errors here because this is co-reference resolution, and it's one of the more challenging NLP problems. And I imagine this is only going to get better as time progresses. We see Ron, Weasley, Ickle, Ronnie. I think I've covered this a little bit in the very first video of this series, but that's the first category there. The next category is major entities. These are all the different entities that were found and extracted, divided by category. So FAC, so Privet Drive is referenced 14 times, and you can kind of keep on going down this list. You get a list of all the different entities referenced. And this is the next nice thing. You've got the actual text where you've got everything annotated based on the entity level. So Mr. tells you this is 364. It gives you the unique identifier. So this is the unique identifier for this particular Mr., which is Mr. Dursley. Mrs. Dursley, we see 92 with her unique identifier. And this is really useful when you get to pronouns because it links up who you references. In this case, it's just a generic you. Again, this is going to be one of the more challenging problems in NLP, which is taking in a pronoun and doing co-reference resolution, but we see it done successfully right here. He is a pronoun, but it's successfully connected to 93 Mr. Dursley, which in this case it is. He was, and it goes on and explains who he was. And again, you can see all this stuff kind of annotated for you in the actual text output. So if you scroll all the way down, you've got the entire book here now referenced. So that's going to be all of the files. Now, what I want you to do is spend a little bit of time kind of looking at them before you move on to the next video. And the next video, we're going to start, and this is going to be added into the textbook after I record this. It's going to be chapter 4, which is going to start analyzing these files. So using Python and some scripts to import the data and extract the useful stuff that you want to see. This is already done in the nice and handy Google Colab notebook that is put out by BookNLP, but I'm going to add some other things into this mix so that you'll have some basic scripts for taking in this data and doing some cool stuff with it. That's going to be what we look at in the next chapter, and then we're going to do all that again for historical documents. So leveraging BookNLP to analyze historical texts. That's going to be it for this video though. Thank you for listening. As always, thank you so much to all the Patreon supporters. If you get a lot out of this channel, please do consider supporting it via Patreon or by joining the YouTube memberships down below. I keep everything for free, so your contribution doesn't necessarily give you a lot of extra perks. It just helps support the channel and keep it alive and buy me some coffee so that I can keep on making these videos. Thank you so much for listening and have a great day.